Hi there and welcome to Code Framer. So in this video we will solve one more problem related to recursion, which is to find the sum of digits of a positive integer using recursion. And this will be the last video where we will be solving problems related to recursion. And at the end of the video I'll just recommend you certain platforms where you can go and search for more problems related to recursion, and you can basically practice by solving all those problems. And this will really help you to understand recursion completely, and those exercises will definitely deepen your understanding. So having said that, let us go back to this problem which we are going to solve in this video. So first let us try to understand what the problem statement is. So here we are trying to find sum of digits of any positive integer. So say for example, if we want to find sum of a positive integer 10. So what are the digits in this particular integer? So the digits are 1 and 0. Now how can we basically find the sum of these two digits which is inside this particular integer? Because remember that when you will be writing the function, you will be giving an input, and that input will be the integer itself. Now you need to fetch the digits inside the integer. So if you pass your input as 10, then basically you will have to find the digits which is inside the integer. So as you can see that we have 1 and 0 as the digits of this particular integer. So now the question is how we can fetch these digits from this particular integer. So a simple solution to this question is that we can simply divide any positive integer with the number 10, and that will basically give us the quotient and the remainder, and which will basically help us to fetch all the digits of a particular integer. So say for example, if we divide 10 by 10, then as the quotient we will get 1, and as the remainder we will get 0. So as you could see here that we have basically fetched all the digits of this particular integer. Now let us take one more example. Say for example, if we want to fetch the digits of a number 54, then we can simply divide it by 10. So if we divide 54 by 10, then as you can see that we can get the quotient as 5 and the remainder as 4. So again we have fetched all the digits of this particular integer. Now let us take a 3 digits number. So say for example, if we want to fetch the digits out of a number 123, then if you divide 123 by 10, so as you can see here that we got the quotient as 12 and the remainder as 3. And now if we further divide the quotient with 10, which means 12 by 10, then it will give us the quotient as 1 and the remainder as 2. So as you could see here that all the digits of this number 123 are now separated, which means that we can use these digits individually and process our result, which is to add these numbers. So this is how we can fetch the digits out of any positive integer. So having understood this, now let us see that how we can write a recursive function which will split a particular positive integer and fetch all the digits out of that integer, and finally it will also add those integers together in order to find the sum of digits of that positive integer. So as I said in the earlier videos that whenever we are trying to write a recursive function, then the first thing that we have to find is the recursive case. So how we can find the recursive case in this particular example? That is the question. So in order to understand the recursive case, or in order to find the recursive case, let us take one more example. Say for example, if we want to add the digits of a number 112, then what are the steps that we will carry out? So the first thing will be to divide this particular number with 10, and when we divide this particular number with 10, then we will get the quotient and the remainder. So what will be the quotient? Quotient will be 11 and the remainder will be 2. So in this particular step, basically we can use this remainder 2 as the result, because we will have to add this 2 later with other digits that we are going to fetch from this particular number. So if you see here that we have already fetched the last digit of this positive number, right, which is 2, because we are trying to add all the digits from this number, which is 1, 1 and 2. So as the remainder of this particular step, we have actually fetched the digit of this number, the last digit of this number, which is 2. Now we need to fetch the remaining digits from this number. So what is the step we can perform? Again, the quotient that we have received in the step 1, we can basically divide it by 10 once again in the step 2. So in step 2, when we divide 11 by 10, then we get the quotient as 1 and the remainder as 1. Now here as you can see that in step 2 we have fetched one more digit from this particular number, which is 1, which you can take as the middle number. And finally we have one last digit to be fetched from this particular number. So what we can do is we can again divide 1 by 10, and as the quotient here you will get 0, but as the remainder you will get 1. So basically in all these steps we can use the remainder to add with the previous remainders that we have fetched, and that will give us the result. So as you could see here that we have remainder 1, 1 and 2, or you can say 2, 1 and 1, which is 4, and which will be the output of this particular positive integer. So this looks like a recursive case, right? So now the question is how you can basically represent this particular recursive case in an expression. So if you want to write this particular recursive case in an expression, then you can say that f of n, where n is a positive integer, will be equal to n modulus 10, which is nothing but the remainder which we will receive when we divide this particular positive integer n with 10. So n modulus 10 plus, then we can call the function recursively by dividing it with 10. So if you remember that the quotient that we received in each and every step was by dividing the positive integer with 10, and that is exactly what we are doing here. So we are basically adding the remainder and then we are calling the recursive function once again with the quotient that we are getting in that particular step, which is to divide the positive integer with 10 and then call the function recursively. So this is how you can express the recursive case of this problem. So I hope that it made sense, but don't worry if you are not able to understand it right now, then bear with me for some time because I'll be coding this now, and after that I will clearly explain you that how this particular recursive case is working in the background. So now since we have found our recursive case, now it is time to go forward and find the base case of this problem. So I'm sure that by now you would have guessed the base case from the last example that we saw, where we found the sum of digits of the number 112. So if you notice carefully in the step 3, the moment we reached quotient value as 0, or you could also say when the value of n became 0, after that point you wouldn't require any recursion to go further. So by that logic, we could take that as our base case, and that is exactly what we are going to do. So when n is 0, then simply return 0, and this will be our base case. So now having found both the recursive case and the base case, now let us go to the editor and start coding. So first let me create a function and we will name it as sum of digits, and this function will take a positive integer as the input parameter. So we can say that it will take n as the input parameter. So let us first write our recursive case. So what was our recursive case? For any positive integer n, it will be equal to n modulus of 10, and it will be added with recursive call with n divided by 10, which is nothing but the quotient of that particular step. So this was our expression. So now in order to write this into our function, we can write return, and then we can write integer, and inside that we can write n modulus 10, and then we can add it with the recursive call, which is to call the function recursively sum of digits, and inside it we can pass the argument as n divided by 10. And here watch closely, I will give n /10, and the reason for that is I don't want any decimals to go as the input to my recursive call, and that is the reason why I am giving /, because it will give me the quotient in absolute numbers, or you can say whole numbers. So this will be our recursive case. So having written our recursive case, now let us write our base case. So as I said, our base case was pretty simple. So we can simply write if n is equal to 0, then simply return 0. So now after having written our base case and the recursive case, now let us try to execute this particular function with different values and see whether it is giving us the desired result or not. So first we can pass an input positive integer. So we can write print, and inside that we can call our function, which is sum of digits, and then we can write, say for example, 12. So if we execute this function, then as you can see that we are getting the result as 3, because 1 plus 2 is 3. But let us give one more input with 3 digits this time. So if we give an input parameter as 1, 2, 3, then as you can see that we are getting the result as 6. So which means that for different inputs our function is giving the desired result. So both our base case and the recursive case seems to be working absolutely fine. Now let us move to the third step, if you remember, which is to write the edge cases. So never forget writing edge cases when you are writing any recursive function. And that is exactly why in all my previous videos also I have written the edge cases also along with the base case and the recursive case, because next time when you write any recursive function, it will come naturally to you. If you are following all these videos, then it will come pretty naturally for you to think about all the edge cases after writing the recursive and the base case. So now time for you to think about the different input parameters which could probably break this particular function. So pause this video for a moment, think about different input values that could break this function, and then see the solution. Okay, so I hope that you would have given it some thought. So the first edge case that I could think about is that the input parameter cannot be a negative value, right? Because it doesn't make sense to calculate the sum of digits of a negative value. And in fact, in the problem statement itself, it is given that we will have to find the sum of digits of a positive integer only. So in order to handle this particular edge case, we can simply write if n is less than 0, then we can simply return invalid input. So by writing this conditional statement, we have basically handled the first edge case, which is to ensure the input parameter that we are giving has to be a positive integer. Now the second edge case that we could think about is that the input value that we are passing cannot be a non-integer. Like you cannot pass a string value, right? Because passing a string value or any other non-integer value, like say for example a float value, doesn't make much sense, right? Because we have to find sum of digits of a positive integer only. So which means in order to handle this particular edge case, we can simply write if integer of n is not equal to n, then in that case again we can say invalid input. But when it comes to writing these messages invalid input, you could be more specific about the kind of edge case that you are handle while writing the recursive case. But yes, just to give an example, I'm just using the same message to the user that the input is invalid. But you could definitely think of a more specific message if you want. So these are the edge cases that we could write in order to handle all the wrong inputs that could be provided to this function and which could probably break this function. So now after having written these two edge cases, I think our function is much more stable. So if you just now pass some negative value into this function, then as you could see that we are getting this response message saying that it is invalid input. So this is how you write recursive function, and this is how you basically solve different problems related to recursion. So now it is time to solve as many problems as possible in recursion so that you get completely comfortable solving any problem and basically to think recursively in order to solve a problem. So in order to find the problems related to recursion, you can simply Google Geeks for Geeks recursion problems. I really like this platform a lot because they give wide variety of problems on a particular topic, and they take you from medium or beginner level to advanced level of problems. So once you give Geeks for Geeks recursion problems in Google, then you can go to this particular link, recursive practice problems with solutions. So if you come here, then as you can see that there are many problems given here, and you could use all these problems and solve these problems to get used to recursion. So there are problems related to strings, there are some basic problems, then there are some problems related to arrays, stack, linked list, binary tree, dynamic programming, sorting. But at this point, if you are new to data structures and algorithm, then I would recommend you to just solve the problems until strings. So you can solve basics and then you can solve the problems related to strings. This should give you a lot of practice and a lot of confidence, and that is something very important. The more and more problem you solve and the more you struggle with these problems, the more and more confidence you will get, and which will help you to get really comfortable to solve problems using recursion. The next platform that I would recommend is to solve it from LeetCode. The best part about LeetCode is that not only it gives you a lot of problem, and not only you will just solve problems, but also you will solve problems efficiently, because LeetCode cares about efficiency of the solution that you have given, and it will judge your solution based on time complexity and space complexity. And that is something really good because it really helps us to optimize our solution. So after having found the solution, it is equally important that you revisit your solution multiple times and analyze how you can basically improve the solution by reducing the time complexity and the space complexity as much as possible. And also LeetCode compares your solution with other solutions that other programmers have given, and basically it compares your solution with the best solution available for that problem. So if you solve problems related to recursion from LeetCode, then not only you will find the solution, you will also find efficient solutions to recursive problems. So if you write LeetCode recursion problem in Google, then you can simply open the first link, recursion LeetCode, and as you can see here that there are many problems related to recursion here, and you can just solve all these problems. But first try with all the easy problems that are given here, and then if you get really comfortable, then you can go for medium. But don't solve hard problems at the beginning. Do not do that mistake. First start from easy, get really comfortable with recursion, and then start solving medium level problems. And finally, once you are really comfortable and you are able to think about solutions related to recursion faster, and also you are able to generate efficient solutions, then start solving harder problems. So having said that, I hope that you are able to understand recursion well in this particular section of this tutorial, where we discussed about what is recursion, what are the different steps using which you can write a recursive function, and also we solved different problems, and I also explained how basically we have to think while writing a recursive function. So from the next video, we will start one of the most important concepts when it comes to data structures and algorithm, which is to analyze any particular algorithm, and we do the analysis by using the big O notation. So from the next video, I will start explaining about big O notation. As I said earlier, that it is one of the most important concepts when it comes to programming in general. So having said that, I hope that you enjoyed this video. If you like this video, then hit that like button, share it with other code lovers, and also subscribe to CodeFramer for more videos. Thank you and see you next time.